When talking about derivatives in calculus, what we're really asking ourselves is, what is the slope of a tangent line at any given point on a function? For example, we'd be asking, what is the slope of this line at this specific point? Before we can do that, let's go ahead and take another point on this function, because we know how to find the slope of a line when we have two different points on that line. So let's go ahead and say that this first point is A, so we know that the corresponding y value is going to be f of A, and the second point, let's say this distance between these 2 points is going to be h, so the second point will be A plus h, and the corresponding y value to that point is going to be f of A plus h. So we know that the slope of a line is the rise over the run. So if we wanted to go ahead and find the rise real quick, we could say that that's this distance right here. In order to find that, we can take this distance, f of A plus h, and subtract off the shorter distance, f of A. And for the run, we could say we want this distance right here. But since we've already designated that distance as h, all we need to do is write h. So if we wanted to ask ourselves, what's the slope of the original line that we wanted, what we would have to do is we'd have to take this second point and we'd have to march it closer and closer to our original point. This effectively would be making h smaller and smaller as we approached A. So we could say we want the limit as h approaches 0 of f of A plus h minus f of A all over h. So this is going to be the definition of the derivative. One way it's notated is going to be f prime of A. Other ways you might see this, you can see this as y prime, you can see this as dy over dx, and there's many other ways you can see it, and it all means the same thing. So for example, let's say we have some function x squared, and we wanted to find the derivative of this. Using the definition, we could say the limit as h approaches 0 of x plus h squared minus x squared all over h. This can be simplified to the limit as x approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. We see here that our x squareds can be canceled out, and we are left with the limit as h approaches 0 of 2xh plus h squared all over h. We can cancel out an h from top and bottom. This will leave us with the limit as h approaches 0 of 2x plus h. And if we plug in h equals 0, we're left with 2x. So this says that f prime of x is equal to 2x. So this is giving us a function to find the derivative of the slope at any point. So let's say we wanted to find the slope at the x equals 2. This would be 4 when we plug in 2, and that's saying that on our function x squared at x equals 2, our slope is going to be 4. This is the definition of a derivative with an example.